Welcome to all of you. In the last class we did the first part of this overview of electric vehicles in India chapter. We actually talked about what is an electric vehicle as compared to a petrol, diesel or internal combustion engine vehicle. Today we will put Indian context more and try to give an overall policy perspective. Having learnt what is electric vehicles, we will get into a little more deeper and raise issues before we start with trying to understand how does a vehicle move and what are the forces applied, etc., etc. So, the first thing, why is there so much interest in electric vehicles? Over last 5 years, huge interest. A very simple reason, the petrol and diesel vehicles are thing of the past. It is a matter of time before electric vehicles will take over, and that is the prime reason why there is so much interest in electric vehicles. What are the clear benefits? Very clear. The first benefit is the pollution. I do not know whether you know that 14 of the 20 most polluted cities in India, polluted cities in the world are in India. 14 of the 20 most polluted cities, and all of us kind of notice that. Now we drive any big city, Chennai, Kolkata, Delhi, Bombay or any of the big cities, highly polluted. Now electric vehicle has no tailpipe emissions and therefore will not have that pollution. I think that really makes a huge difference. The second reason is we are very badly impacted by the petrol import bill. The petrol import bill has been going up and up and up every year. If you look from 1980 onwards, it has been going up, and though it temporarily came down, it has gone up, and today is huge. Of course, oil imports is the largest import in the country, but it is really hurting our economy like anything. If there is a way by which we can stop this import, it can make a huge difference. Our economy will grow much faster. These are the reasons why we would like to see electric vehicles. But technically, one of the key reasons is basically electric vehicle is 4 times as energy efficient as a petrol vehicle. Purely in terms of the energy efficiency, if you take so much of energy, a certain quantity of energy, how much energy is required to drive 1 kilometer, and you find that the petrol vehicles are 4 times worse, 4 times. And for example, internal combustion engine has basically 22, 23, depends on the size of the efficiency. I mean, only the total energy that is there in a petrol or diesel, only 22 to 23% of that is used in a vehicle. The rest is all wasted. The internal combustion engine are not more efficient than this. Of course, some of the recent vehicles are recovering some of the energy and reusing, so the efficiency can go up, but only to some extent. On the other hand, electric vehicles starts with a vehicle efficiency of around 90%. So, the 4 times more energy efficient. The second reason, it has a very few moving parts. A petrol engine has huge number of moving parts. Electric vehicle has very few moving parts. How will it help us? It basically means maintenance will be much less, it can last for much longer, it is a simpler vehicle, and therefore there is a huge interest in electric vehicle. So, where is the problem to switch to electric vehicles? Why would you not switch? And I kind of indicated that last time, but I think I will get into more. The key problem is energy storage, the batteries. Its weight is a problem, volume is a problem, cost is a problem, and all three are related. Larger weight means larger material usage. It is the cost of materials primarily. Of course, that will also make things larger in size, and the cost goes up. Cost is directly proportional to the weight and volume. What is the unit that we used for measuring energy? I mentioned in the last class, it is watt hour. 1 watt being used for 1 hour is a watt hour. For example, a 30 watt bulb uses 30 watts for 1 hour. So, then it consumes 30 watt hour. In electricity metering, we normally call something called a unit, which is 1 kilowatt hour, 1000 watt hour. Basically, it could be a 1000 watts used for 1 hour or 100 watt used for 10 hours. That is a unit of energy. A small home in India consumes about 2 units of electricity in a day. That to understand what are we talking about, we must do that. This is the basic thing. The 2 things that matter most is what is called gravimetric energy density and volumetric energy density. Both are energy density. One is in terms of watt hour per kg. If I take 1 watt hour, how many kg will it weigh? Or 1 kilowatt hour, how many kg will it weigh? So, basically measured in terms of watt hour per kg. Other is measured in terms of volume. So, watt hour per liter. If I want 1 kilowatt hour, what will be the size in terms of liter? Liter is 1000 cc. So, a home assignment that I am giving it to you, please look at the web and please find out what is watt hour per kg and watt hour per liter for petrol, for coal, for wood. These are all sources of energy. Find out what is the watt hour per kg and watt hour per liter, and as compared to that, of course, electricity is electric battery will tell you what is the watt hour per kg and watt hour per liter. So, how much can we store in electric battery, in hydrogen fuel cell? These are the key issues that we have to consider and make sometime the electric vehicles into a problem, and one needs to develop that. For example, gravimetric energy density, which I talked about in terms of watt hour per kg, the cells that are used today commonly are NMC and NCA cells. If I look at the energy density watt hour per kg, it has been going up and up and up. What does it mean? Basically, you can get more out of 1 kg of the battery. 1 kg of the battery earlier used to give only 80 watt hours, now 310 watt hour. So, basically 3 kg I can store 1 kilowatt hour, that is a battery 1 kilowatt hour. Now, earlier I needed 12 kg of materials. Since primarily the cost of the battery cells are dependent on the cost of material that is used, lithium, manganese, cobalt, nickel, graphite, the cost was very high when it was 80 watt hour per kg. Now that it is a 310 watt hour kg, the cost has come down, and you see the cost coming down. In 2011 it was $800 per kilowatt hour, it has come down to $110. It has really slipped like anything. So, significant decrease in cell prices as watt hour per kg increases. Okay. Now, so this is the point that I am making, and this has been changing. This is the biggest development that has taken place. 10 years back, actually talk about electric vehicle has been going on for generations. In fact, I don't know whether you know or not, 100 years back, we started in the world with electric vehicles, not with petrol vehicles. Petrol was at that time not easy, internal combustion engine was not such an easy thing to do. But that time we used to use batteries which really were very heavy, and therefore consume lot of space. And after that, for a long time, major development did not take place. Lead acid battery, but did not do very well. In fact, lead acid battery has what, 40 watt hour per kg, 30 watt hour per kg, 40 watt hour per kg. And then came all kinds of battery. Lithium ion is one of them that came towards the end, and before that there were several other batteries, we will talk about them. And suddenly we jumped to 80 watt hour kg, which was good but not good enough, and today we are touching 310 watt hour per kg at the cell level. The prices as a result keep falling, because you are using less materials, and over time it is expected that this will continue to go down. We are really looking at 500 watt hour per kg, 700 watt hour per kg going forward. In terms of volumetric energy density, today we are touching around 500 watt hour per liter. So, 1 kilowatt hour will be only 2 liter, 2000 cc, that is a kind of volume. Higher energy density, of course, basically means the battery is storing more energy, and therefore will have higher safety concerns. Something can happen. So, as I pointed out, cost is inversely proportional. So, if there are safety concerns, you have to do something about it. But as we will see, the petrol energy density is huge, is 10 times, even more energy density, more 50-20 times that of these batteries. So, in fact, petrol is in some sense more dangerous. If the smallest spark can finish the whole thing. Now, over time we have tamed petrol. Petrol is no longer considered risky, we know how to handle it. So, this battery with higher energy densities also need to be tamed, you need to learn how to use it. And this is one of the things that we will do in the course, that battery design involves what is called taming of battery, making sure that it is safe. So, 300 watt hour per kg, 500 watt hour per kg is not something that one has to worry about, one just has to learn it to manage it safely. As I told you, petrol water energy density is 12,500, not just 30 times, 40 times. Now, look at the other thing. Battery energy density is 300, petrol is 12,500. Even if I take that from the battery, I can take, because I am using electricity, I can get 4 times higher energy efficiency. Taking that into account, still it will be equivalent to 1200 watt hour per kg, 4 times. So, still there is a factor of 10 times, 10 to 12 times. So, the petrol, you can store a very large petrol to travel long distances very easily. Batteries will become very heavy, and size will become very large, and cost will become very large. So, weight per kilometer will be 10 to 12 times the weight per kilometer of the petrol, and in volume wise it is 5 to 6 times higher. This is the prime problem. Of course, it is improving year after year. It used to be only 100 watt hour per kg, in that case it was much worse, but it has now reached 300, it is better, but it is not going to become 3000 so easily. We will deal with that. So, this is always going to be an issue. It is going to be the petrol vehicles, you can do easily store energy for long distance, not so with electric vehicle. So, this is a simple home assignment that I am asking you to do. You look at the websites and look at watt hour per kg and liter. I have given you the answer. Petrol watt hour per kg, assume that as 12,500, watt hour per liter you assume as 9375, and that answer we have given you. You can look for the sources, you can find that. Take a decent size 4-wheeler, it consumes 15 kilometers per liter. It is a very good vehicle. Equivalent electric vehicle consume only 150 watt hour per kilometer, and use that to compute the ratio of the energy efficiency of EV versus ICE. So, you do this, I think we have done enough to be able to figure this out. One of the concern that you will always have, petrol, as I told you, petrol tank is very small cost, battery is very large cost. And then you reuse again and again and again until the battery becomes not usable. We talked about it. So, how do you compute that if I use it for 1 kilowatt hour, how much is the cost? Remember, there is a capital cost involved, and the capital cost which is depreciating fast. Depreciation basically means value is going down because the battery is no longer going to remain the same. So, since the battery's capital cost is going down with number of cycles, and any time I use the battery, I put in this is a container cost, remember, I put in certain electricity, take it out, how much is the real cost? For petrol tank it is negligible. This is quite high. So, how do you calculate this? Of course, you have to compute, get the number of cycles, as I told you, cycles will reduce. So, you will take into account what is called depreciation and interest. Now, this is some small amount of economics I want you to learn, very useful, because on the one hand, what is the total cost of usage will become, there is a petrol tank cost plus petrol cost. Petrol tank cost is negligible. So, it is only petrol cost. You only ask the question how much liter of petrol is used for a kilometer, and based on that you can calculate. In an electric vehicle, you have to take capital cost of battery into account, plus the cost of electricity, and find out how many watt hour per kilometer, and then compute what is the total cost per kilometer. And therefore, you must do depreciation and interest cost, and operation cost will include fuel cost. In this case, it will be the electricity cost. Of course, there may be a charger cost and filling and all that, but those are negligible. Can we learn to compute cost of 1 unit of electricity that I store and take out of different energy storages? So, energy storage is very of different. The storage cost for petrol tank is negligible. What is the cost of the battery? What is the cost of coal if I store it? What is the cost of any other thing? I store energy, whatever stores energy. So, this is what we will do. Remember, there is also one more cost that I need to take into account. Very often, hardly anyone ever takes that into account. If my battery is, I am going to start with, and battery after a certain number of cycles is going to become useless, is there going to be environmental cost in taking that battery out and throwing it? If I throw it, should I throw it? Is there something else that I can do? So, this will be one of the key things that we will take into account. Another concern will be, and very often it is raised, yes, you can use electric vehicle, but finally the energy is coming from coal, and coal is generating a lot of pollution and greenhouse effect and all that. Of course, pollution is not there where you drive, but somewhere it is getting generated. This question will often come saying no, electric vehicle is not as good. Actually, questions are posed quite a bit by the petrol lobby. They want to try to show that electric vehicle is not as environmental friendly. Now, the only answer to be that if you have this kind of batteries and you have to use electricity, why not generate electricity from solar and wind, renewable sources? You can use that. Then the only thing that you have to worry about is that what will happen to the battery once it is over. Everything else will be renewable. There will be full circular economy. And what we will teach in this course also, that the battery can also be recycled to recover the material in an environmentally friendly manner. So, if I am using solar and wind electricity, based electricity, then I am charging a battery, and once the battery runs out of its capacity, I use it wherever I can, and after that I recycle the material and reuse the battery, and therefore my environmental cost can be negligible. Of course, one has to work on that. It does not happen automatically. Lots of work needs to be done to be able to do that. So, we will learn to calculate, but battery cost is not small. It will come to, in India today, between 12,000 to 15,000 rupees per kilowatt hour for a decent size battery, not for 1 kilowatt hour, maybe for 5 kilowatt, 10 kilowatt hour battery. We will learn to compute that the cost will come to around 12,000 to 15,000 rupees. That number should stay, that is what the number is. If it is only a 1 kilowatt hour battery, it may cost slightly higher, 18 to 20,000 rupees.